First off, thanks, Jane, for sharing your story. That was really, really cool to hear. That sounds like it took a lot of perseverance, which is sometimes what's needed for what we do here. So today I wanted to talk to everyone about REST and GraphQL. GraphQL is certainly a technology that you'll hear the name of quite frequently if you're doing any sort of online learning, if you're looking for a job, if you're looking at what boot camps are teaching or what jobs are looking for. And it's helpful to know just kind of the history. There's a longer history than just REST to this. If you ever hear about SOAP, then that kind of plays into this history. But whenever I'm teaching folks, like front-end folks who we're talking about the DOM and jQuery and React, or back-end folks talking about servers moving into PHP or Node.js or whatever, it's always helpful to kind of enter into that history to know a little bit about what's going on. And so today I'm going to talk about REST and its what that is, if you ever hear of APIs or RESTful APIs, and then kind of the new emerging future of what that looks like in GraphQL, and a couple of concepts there. So first things first, what is REST? It stands for Representational State Transfer. It refers to kind of the constraints of what architecture for client-server communication data exchange should be. So that's a big mouthful. What that means is it means like, okay, so everything's working on the internet, everything's, sending, messages out over the internet and receiving them back. So then what is that supposed to look like kind of at the application level when you're writing your code? And so REST is designed to kind of give some guidance and constraints in order for people to write applications that way. And in case you're wondering, if you've not looked at this level of code yet, everything, all applications interact with one another through some sort of interface, some sort of API. If it's over the internet, it's probably a RESTful API. And so it's very important for us as developers to know these concepts. So yeah, so that may not be helpful for some of us. So really, seriously, what is REST? So the two big ideas behind REST are, one, resources, or uniquely retrievable resources. So that's where we get the idea of like a URL or URI, if you've heard that terminology before. And then the second is verbs. So first to the resources. The resources are what's reflected in your URL, which we'll get into what the anatomy of the URL is in the next slide. And each of those URLs represents that application's data and what that, what underlies that data. So whenever I want to get blog posts, for instance, then I look for a certain blog post by ID or whatever. Again, we'll get into that in a second. But the verbs is another big important part to this. So many of us, if you've heard of like CRUD, create, read, update, delete, the basic actions that you take in applications with respect to like databases and persistent data that persists across sessions that a user has with an application, then you have these actions. Loosely speaking, they're not tied together in any way, but loosely speaking, the REST verbs relate to those actions. So get means I'm getting something, put or patch means that I am updating something, delete means I'm deleting it. Post is I'm sending data in, typically if I want to either create something or in some instances change it. And there's a bunch of other ones, options, trace, head. You'll see those in your browser if you ever open up like the network console. You'll see applications making those types of requests. They're not as important. They're used for kind of secondary and tertiary actions within applications. They are important, but typically whenever you're looking at like API documentation for an application you want to integrate with, you won't need to know those as much. So then, breaking it down to its most elemental sort of pieces, REST is you have a URL endpoint, you make a request using HTTP, using one of these verbs, and then the response comes back in a predefined manner from the server that you call or the application that you call, and that lines up with whatever the documentation is or whatever a good REST design is. So anatomy of a URL. So again, so a URL represents what that thing is in the application, whatever that might be. So real quick, so the first part, as we know, is the protocol HTTP, HTTPS. Sometimes we might see file system. Sometimes we might see WebSocket, WS. Those just represent the protocol, but everything over the internet is HTTP, right? So that's why everything starts with that. Then you have the actual host or the domain, and then the port. Typically that is abstracted away from us. So we just have a domain or a subdomain, a domain, like in the case of the example, api.github.com. Then you might have some other context, like if a domain hosts multiple types of applications, then you might have different applications that you can hit on the next kind of part of the endpoint. And then you have a version. That's just good design for if you're designing an API for someone to call so that you can change those out easily. Then all that to the side, that's kind of just like, okay, that's just good to know information. But typically it's kind of like, okay, I just copy and paste that from documentation, no big deal. The second part of this, the end part of this, is really kind of what is interesting with regards to REST, because those endpoint URLs, these slashes at the end, are supposed to accurately represent, again, what the data is getting. In this case, it's like users, and then I'll have an ID if I want to get a specific user with that ID. In the case of the example with GitHub, it's like, okay, what are the concepts behind GitHub? Well, we have these users, and these users have these repositories, these Git repositories with source code in them. So in my case, if you wanted to do a request, and you couldn't do this in browser or Postman because you'd need authentication, but you could go to this is my personal user profile, go to users, then go to my username, because GitHub has unique usernames, so you don't have to use a unique identifier. You can just use a username, and then repos. And essentially what that's saying is, okay, I know that there's a user out there. I know that it has this username or this user ID, whatever. And then I know that it's related to a bunch of repositories. So this is how I would get all of those to come back to me in a response from that server. So again, standardizing the way that these applications talk to one another, so that everyone can kind of speak the same language, so to speak. So the thing to note about how, like, what's going on in this conceptually speaking, well, I want to point you to two resources that I think are really great. One is a guy named George Fairbanks. He spoke here in Oklahoma City. He's written a book called Just Enough Software Architecture. If you're interested in kind of the architecture world, very good resource. And then Graffiti is actually an application, an open source library. But on their website, graffiti.dev, there is a why would I go with this over GraphQL? Very, very interesting read. It gets really in the weeds, but I always like reading those types of articles because I think they help me understand why really, really smart people make the decisions that they do. That really, at the end of the day, again, these are models or representations or entities. You'll hear all that language used for the data that this application represents. So in the case of like an HR application, right? You're going to have a company. That company has a one-to-many relationship to employees, and then each of the employees can have one or many positions. And so you might represent that in JSON in that image to the right. Kind of like that, like you have the name, there's properties that represent that particular employee, but then they also have positions, and then that has other objects that are representative. Another example is very, very common, like blog post comments. A blog has posts, and a post has comments, and so you might represent that in a certain way using /blog /1/ kind of like I did with API v1, companies, company 123. So that's a specific company, and then all the employees of that company. Another one, obviously, with e-commerce, customer and customer orders. Those are real life kind of objects or real life things going on that we're trying to represent using technology. And this is why I recommend George Fairbanks, actually, because one of the things he says is, hey, whenever you're writing code, whenever you're learning this craft of software development, know that what you're trying to do is you're trying to make it to where, you know, you're taking something in the real world and you're representing it in technology, in code. And the better you can do that, the better you can, he uses the word argue, the better you can argue your code or your technology to the real world, often the more sustainable, maintainable, and understandable that application is. Okay, so all that has to do with REST. And I'm sure there's a lot of questions or a lot of things. There's plenty of other resources you can go to, and I recommend kind of touching up on those. But then where does GraphQL come in? Like I said, GraphQL is a similar way of representing these real life models of the data underlying. But the name graph comes from, you know, in the software development world, people are leaning on kind of some concepts in mathematics to represent what data looks like. And they would argue that this is actually how we're thinking of it all along. This is just kind of language to put to that. That is way in the weeds. If what I'm talking about is in the weeds, that's like way off in left field. So if that is a little too much, it is interesting to note. But this is something that I see a lot of it impacting a lot of how things are designed, how these third-party libraries that I use every day, how they're designed, all of that kind of thing. But GraphQL, instead of it being where you make different types of requests to a host of different endpoints to get the information you need about, like making a GET request to the blog and then getting all that blog's comments and that sort of thing. This is just a single endpoint. It's a post request to a /GraphQL or some predetermined endpoint that represents that GraphQL server. But that request must include a certain schematized query for the information you want. So if I wanted, you know, blog, certain properties of blog, but then I also wanted all the post with the comments, then it brings back a kind of nested data structure that represents all that information. But instead of going to each of those endpoints, like I would with REST, I'm going to one with the query that I want. So the server responds with the represented data that I have requested in the query. A really, really good talk. I actually first started kind of learning about GraphQL when Aaron Krause gave, he's a Techlahoma member and user group leader, gave a talk about it at OKC Web Devs. This is if you want to kind of take a snapshot of that video link or that unique ID right there, I can post it in the comments as well. Or you can message me on Techlahoma as well. I'll send it to you. But you can also just Google how to GraphQL, Aaron Krause, OKC Web Devs. It was the first thing that came up. It was a great talk. So then let's kind of compare side by side. So in this case, this is two different servers or two different architectures, let's say. There's a GraphQL client server and a REST client server. We'll start with the REST side, which is on my right, or is on the right, should be. If I wanted to get an album and then get all of the assets for that album or whatever, then what you would do is you would say, you know, I want to get to albums. I have a certain album ID, and then I get the assets. But then if I also wanted the comments, then I would also have to go do a GET request to assets, asset ID, comments. So in other words, you're representing it in multiple endpoints and multiple calls. Whereas with GraphQL, I can say, I want the assets, and here's the specific album ID that I want. And I also want all of the comments. And so essentially what's going on here is, again, I'm making multiple calls with different verbs. with the REST side. Or with GraphQL, I'm making a post request to the GraphQL server with my query, and then that will return to me the data that I want with the relationships that I want as well. Another way of kind of representing it is this right here. So one of the benefits of GraphQL, again, is that it's a single endpoint. So post, comments, authors, I could get this all in one call there with a GraphQL API. With the REST API, I would need to make multiple calls. And this does come into play with some practical concerns. It's not just easy. It's not just trying to make it easier or more smooth for us, though that is important. It is important to make developer experience good. But also, like, so for instance, I do some development work with some clients that we do a lot of serverless. And what that does is it allows us both to not ever have to worry about servers or anything like that. So we essentially what I'm doing is I'm just writing functions that integrate with some third-party software using a RESTful API. But then let's say that in order to get all the data I need to go through a list of posts in this example, and then also get all the comments and all the offers for that post. Well, what's going to happen is my code is going to loop through all of those posts, make API calls to all of those to get the comments that I need, and then make other multiple API comments in a secondary loop in order to get all the authors. In other words, for each item, I'm having to make API calls to that end resource to get the data that I need and then structure it and then return it to the application. With GraphQL, I can do that with one single call. And that may be important because you may be trying to save money. I know that in number of invocations is one way that a lot of serverless cloud providers charge. So that is there's some practical consideration here. So let's take a step back here in a second. I want to say that no matter what happens kind of in the technology you use, am I going to go with REST, which is kind of like your gold standard a little bit, it's well used, and more APIs than not are going to use REST than either the previous technologies before REST or technologies after, at least for now in the foreseeable future, probably the next 5-10 years, I would say. Well, it really doesn't matter. There's pluses and minuses to both. And I would say that the things are moving towards GraphQL, but we as developers need to know REST, and we need to know the concepts behind REST. But what I want to point out is this. To make a good RESTful API, you have to understand what is behind making good software. So I love talking about like design and architecture and things like that, because all of us, even from our beginning stages of learning how to code, are making decisions on how to build applications. If you're starting a project and you're trying to do something on your own and you're not just following along, one of the biggest things that people get kind of like stuck with is, how do I represent this data? And oftentimes for me, when I'm working with clients in my consulting business, that's the first thing I'm doing is I'm kind of building a mental model of what their business needs are as I'm talking to them. And then from there, I have kind of this, they call it domain-driven design, but I have this domain of knowledge that they've kind of given to me from their business experience. And then I can try and best represent that in the technology in the best way that I possibly can. And if I do that well, and I understand them and we communicate well, then essentially I've brought the technology and my client closer, which means I'm bringing my user and the technology closer. And that is typically going to be beneficial in the way they use the software and its marketability and essentially their experience with it. So I think it's very important to keep in mind. So essentially what you're doing in anything is you are using a schema of some sort, because even in REST, you're using schemas. So the schema example on the right would be like a GraphQL example. It is saying this is what a book looks like. Here's all the properties of it. Here's what an author looks like. Here's all the properties of it. Oh, and by the way, it's related to books in this way. Well, the thing is that you are doing that whether you know it or not. And so that's the reason, like, I'm a JavaScript guy. That's the reason I recommend TypeScript or anything with strong types that I can start to represent what the data is going to look like before we actually get into it. You're doing it with ERD if you're doing like a relationship design in a database, or if you're doing it in your code yourself first. Either way, representing your data well is a very, very important place to start. And so regardless of whether you go with REST, go with GraphQL, you probably need to learn both, but just know that designing and representing data well in learning how to do that in whatever way you can, whether it's TypeScript types, GraphQL schemas, drawing out ERDs or entity relationship designs in databases, whatever it is, that's an important skill to software development. I think with that, that is it.
All right, thank you, Devon. Let's see if we have any questions real quick. We have one. What are some drawbacks of GraphQL?
Yeah, drawbacks. One of the biggest drawbacks you'll see developers kind of comment about with blog posts and whatnot is just the amount of boilerplate that you need. So one of the things that's hard is that, we're, as software developers, we're in a golden age of having all the tools we'll ever need available to us, I feel like. There's so many tools out there to use. But anyone who's used kind of like a kind of out-of-the-box thing to create an application, like Create React App is a good example, or using GraphQL has Apollo client, it takes a ton of code to make that developer experience seamless. And so if you're trying to build like a GraphQL server out of the box, there's a lot of code that has to go into it in order to tie everything together. So it's not very beginner friendly from that experience. Compare that to creating, like if you're a JavaScript person, a Node.js server. I could show you in 3 minutes how to create an Express server, with NPM and all of that. And so, designing some routes, kind of saying like this is kind of what we're going to do. Here's going to be the JSON responses, all of that. And it's literally one single file. And so I think that's going to be one of the biggest drawbacks from the GraphQL side. But, that's just one of those things, like abstraction requires more boilerplate. And something what we do in software development is create better abstractions, better tooling in order to make our lives easier so we don't have to think about it as much.